For example 1, we want to graph the equation of the line by using the x-intercepts and the y-intercept. So let's see, this is my x-axis, here's my y-axis. To find, let's say, the x-intercept, it's not too hard to do for this particular linear equation. What we do is we let y equal 0, and then we solve for x. So let's check that out. I have 4x minus 3y is 12. And I'm going to plug 0 in place of y. So I get 4x. I'll write it out, 3 times 0 is 12. But it's going to nicely cancel, just give us 4x is 12. And when you divide both sides by 4, you get x is equal to 3. So this is an x coordinate and a y coordinate. So that is 3, comma, 0. That's 3 for x and 0 for y. So now I'm going to plot this on my graph. Let's see. Starting at 0, 0, so as to see how this travels. So here's 0, 0. We're going to go 1, 2, 3 places to the right. And we're not going up or down because y is 0, so I should be right here. So let me plot that. Okay. Now, if we get one more point, we know what this equation is going to look like. So now let's try to find the y-intercept. So the place where it actually crosses the y-axis. And for this, we're going to let x equal 0. So I take my equation, 4x minus 3y is 12. I'm going to put 0 in place of x. Okay, so that simplifies nicely again to negative 3y is equal to 12. So now when I divide both sides by negative 3, I'm going to get a negative number, in fact, negative 4. So on my graph, I'm starting at 0, 0, and I go down 1, 2, 3, 4, right here. So that's the y-intercept because we're on the y-axis. And once you have 2 points, the line is just the graph that goes through those two. So it's not going to be perfect, but something like this. And I just want a basic sketch of the graph. And so here's my linear equation. 4x minus 3y is 12. For example 2, again, we want to sketch the graph of this line. It's written in a different way. It's written with y equals, and everything else is on the other side of my equation. So we could still use the x-intercept and y-intercept to graph this thing, but really you can use any 2 points that you'd like. So I'm going to make a table of values. So that is, I'll write x and y. I'm going to choose some numbers like 0, 1, and 2 for x, and then I'm going to try to solve for their corresponding y values by using this equation right here. All right, so let's start with x is 0. If I plug that into my equation, again, it's set up really nicely to do this. I have negative 3 times 0 plus 4, and when I simplify this, I just get 4, and I'll place that right here. I'm going to do that for, you really only need 2 points, but I just want to try it for a couple. So like if we say x is equal to 1, then let's see, my y value is negative 3 times 1 plus 4. So that's negative 3 plus 4, which is 1. So I'll place 1 right here. And then just to get the last one, we'll say x is equal to 2. The y value is negative 3 times 2 plus 4, which is negative 6 plus 4, and that's negative 2. So that's right here. So I can use any of those 3 points to graph my line. I think I'll choose this one, and maybe 2, negative 2. Again, it doesn't really matter, but those are the 2 that I'm going to choose. So for 0, 4, That means I stay at x equals 0 and I go up to 4. So I'll put a point there. Let's see. Okay. And then for 2, negative 2, I go 2 places this way and down 2. So I'm right here. I'll place a point there. Oops. All right, so my line is the equation that goes through those 2 points. So I'll try to draw this one nicely. Something like this. It's not perfect, but just trying to get the idea of what this equation looks like. And there it is. And actually, one thing to point out is we didn't use 1, 1, but that spot's right here. So it does actually fall somewhat on the line that I drew. And 2 points was enough to get my entire equation. And for the final example here, we want to find the slope between 2 given points. So I'm going to start by graphing these points in the xy plane. So negative 2, 5, and 6, negative 1. So for negative 2, 5, that's here. So that was left 2 and up 5. And for 6, negative 1, that's here. I went to the right 6 and down 1. And you could draw a line that goes through these 2 points. There's nothing wrong with that. But the idea of slope is, how do you travel from one point to the next in terms of something called rise over run? So that is a very informal definition for slope, but basically it tells you for the rise, how far up or down do you go? And then for the run, it's like how far to the right, you could say to the left too, but how far to the right that you are moving. So if we go back to, let's say, the point negative 2, 5, I know we have to travel down, and if we do, we go 1, 2, 3, 4, 5. You actually have to go down 6 places. So I'm going to write down that the rise is equal to, it's weird to call it rise, but we'll call it negative 6. The negative just indicating that we're going down. And then from that spot here, the run is 1, 2, 3, 4, 5, 6, 7, 8. 8 places to the right. So the run is 8. And we define slope to be the ratio of these 2 values, negative 6 over 8, the negative indicating down. We can reduce this a little bit. There's a factor of 2 in both of these, so that would be 3/4. So that's interesting. If you think about negative 6/8 versus negative 3/4, all right, negative 3/4, if we start here, would be you go down 1, 2, 3, and then you go 4 places to the right. 1, 2, 3, 4. If I was to repeat this process again, 1, 2, 3, 1, 2, 3, 4, we still travel between these 2 points, but both of those numbers do represent the slope of the line through those points. So that's really it for this question. Once you get this value here, that's the answer. However, there's a more formal definition that we can use as well. And what this does is basically you don't have to count. It just plugs the numbers in and it gives you the correct values back. The y2, y1, that represents your y values. So like this could be your y2 and this could be your y1. How far down did you travel? And then your x2 would be here and your x1 would be here. Oh, that's in the wrong spot. It would be here. So if you want to like write those out, like this x value was 6 and this x value was negative 2. This y value up here is 5. This one is negative 1. So if we plug these into the equation for slope, okay, I'm going to list these out just a little bit more carefully off to the side. So x1, y1, I'm going to call that maybe I'll choose it to be -2, 5. And then x2, y2, I'm going to choose that to be 6, -1. So we'll plug all these in and see what happens. So let's see, the difference of my y's, that's going to be -1 minus 5. And then the difference of my x's is 6 minus -2. If I simplify that, I get -6 over 6 minus a minus is going to be 6 plus 2, so that's 8. And we get the same number, -6 over 8, which still reduces to -3 over 4. So both of these methods are completely okay. I mean, the formula is nice just because you don't have to actually count on your graph. But here our slope was -3/4, and the negative meant that the line was decreasing.